Welcome to today's news. The headlines. Scientists have discovered that there is almost a 0 probability that Apophis, a near-Earth asteroid, will hit the Earth in 2036. A leading university has conducted a road survey on traffic incidents. Young car drivers are 5 times more likely to be involved in collisions than older groups, and young motorcyclists are 20 times more likely. And lastly, from our weather hub, there is a 70% chance of rain today. Today's lesson, we're going to be looking at what the chances are of certain occurrences happening. In the news bulletin you just listened to, we heard a mixture of words and numbers to describe the chances of certain events happening. The 0 probability of an asteroid hitting the Earth. That young cyclists are more likely to collide than older groups. And there's a 70% chance of it raining. So today we're going to compare the use of words and numerical displays to describe the chances of different events happening. If I was to ask you, what is the chance that you will be hit by lightning? How would you answer that? Would you use numbers? Or would you use a word? Perhaps like one of the words I've shown on the screen. Impossible, unlikely, an even chance, likely, or certain. I'm hoping that you're going to say extremely unlikely. Now, this use of words to describe the chances of something happen is called likelihood. And they range from absolute no chance whatsoever, which we use the word impossible, all the way up to absolutely definitely, and that's the word certain. In the very middle then, we have where it's just as likely as it is unlikely. So that's an even chance. And then the areas in between those words, so if it's in between impossible and an even chance, then it's unlikely. And if it's in between an even chance and certain, then it's likely. So I'm hoping that your idea about you being hit by lightning will be very close down here. We can't say it's impossible because we know that these things do actually unfortunately happen. We can only decide that something is impossible if we are guaranteed 100% we're sure that it definitely is impossible. If it's not, but it's not 50-50 either, so there's not just as much chance that it will happen as it won't. And we know that being hit by lightning doesn't happen to very many people and it's not very often. So we can't say it's an even chance. So therefore, it's somewhere in this section. And it's totally up to your own opinion, your own research, your experience to decide whereabouts in between the impossible part and the even chance it lies. The closer to impossible, the more unlikely. The closer to even chance, it's a little bit more likely than it was down here. So I would say somewhere around here. So what we have here is a scale. It's just a straight line ranging from the impossible to certain. So we can call this a likelihood scale, and this can help us to put certain occurrences, like being hit by lightning, onto this scale to describe how likely then it is to occur. You just heard me say that we can only decide something is impossible if it's absolutely, definitely not going to happen. Well, this certainty of picking a particular word and therefore a position on our likelihood scale is also the same for the use of even chance. and certain. Each of these 3 points, we must be 100% sure that the occurrence is exactly, definitely never ever able to happen. Such as if I was to say, what is the likelihood that March will be after the month April? Well, we know that March is before the month April, so it's impossible. And therefore I can say that the likelihood of March being after April is impossible. And I could indicate it here by pointing or putting an arrow on the scale right there by impossible. So the same with the even chance. We can only say that something is exactly here if we're definitely certain that it is just as likely as it is unlikely. So it's like there is a 50-50 chance. You may have heard of that being used before. So an even chance might be for something like, what is the possibility that I flip a coin and it lands on a heads? Well, we know that there are only 2 possibilities, either a head or a tail, so it's just as likely it might be one than the other. So it's an even chance, and therefore we would say that that occurrence goes exactly here where even chance is on our likelihood scale. And then again with certain, if today is Thursday, then it is certain that tomorrow is Friday. We are definitely certain that that is the chance. So it would go exactly here on our likelihood scale. So what about in between then? As we discussed before, it depends on our experience, on our findings, and our opinions. Whether something is likely, it could be here, or it could be here. For example, our chance of it being sunny in Florida tomorrow. Well, we probably know that Florida is quite a sunny location, but we can't say for sure that it definitely will be. So we can't put certain, but it's probably more likely than it is unlikely. So that means I could put it anywhere in this section here, in the likely section. So this word likely represents everywhere from after the even chance, so slightly a greater than even chance, and just before certain, so not quite certain. And likewise then unlikely, like our being hit by lightning, it's greater than impossible, so there is a chance, but it's very, very slim. And then unlikely can still be used to describe anything all the way up to, but just a little bit less certain than an even chance. So here's an example of a likelihood scale with some occurrences placed in correct positions. So remember that a likelihood scale is describing the chance of these occurrences happening with words. So firstly, a meeting with King Henry VIII, well, we know that he is definitely, most certainly past. So therefore, that would be impossible. And notice how there is an arrow pointing to the exact position on the likelihood scale. And that's really important in an exam. We need to be exact and show the examiner where we think it lies using an arrow. A day of the week starting with a T, well, there are 2, Tuesday and a Thursday. So there is definitely a chance, but there are 5 that don't. So it's less likely than it is likely. So therefore we can say it's unlikely, and it could be anywhere then in between impossible and even chance, and we've just placed it then in the middle. The next baby being born will be a boy. Well, it's either a boy or a girl, so there's only 2 options, and it's therefore just as likely it is one than the other, so we can put our arrow to exactly on the even chance. Getting a number, and we have that symbol for greater than a 2 when we roll a fair die. Okay, so that means it could be a 3, 4, 5 or 6. Well, that's 4 out of the 6 numbers that we can get when we roll a die. So there are more options that we are looking at the possibility of getting than there are the ones we don't want. And if there's more options, then it's more likely that we will get that result. It's not certain. We could roll a 1, we could roll a 2. So we can't put it on the certain, but it's definitely more possible than an even chance, because there's more of the ones that we're interested in than not interested in. So we're going to put it somewhere in between even chance and certain, and we put our arrow then to the right of even chance. And then a square having 4 right angles. Well, the properties of a square is that it most certainly does have 4 90-degree vertices. And therefore, it's absolutely certain, so we can put our arrow on the certain, on the likelihood scale. So remember that the less likely an occurrence is of happening, the further to the left it's positioned on the likelihood scale. The more likely something is, then the further to the right. And we can only place things on impossible, even chance, and certain if it's definitely in those locations. Okay, so let's test out and see how well you've grasped the likelihood scale. So where do you think that we would place an arrow to show the likelihood of a fair coin being flipped and landing on heads? So put your fingers on your screen, point to the right location. Well, it should be exactly there. Even chance, just as likely, heads as it is tails. Okay, how likely is it for a letter to be chosen randomly from the English alphabet and for it to be a vowel? Put your fingers on the screen. Well, the vowels are A, E, I, O, U. There's only 5 of them, and there's 26 letters in the alphabet, which means there's a lot smaller amount of occurrences that we're interested in than what we're not. So it actually seems quite unlikely, as only 5 out of the 26 are vowels. So if you chose anywhere from in between impossible and even chance, you definitely can't have it as impossible, and it's definitely not even chance, but it's unlikely. Maybe you put it somewhere like here. Okay, next. What's the likelihood of a standard 6-sided die, so a normal die, like this, being rolled and it landing on a prime number? Well, this one's quite tricky. We know that our primes are 2, 3, 5, 7. Well, we don't have a 7 on a die, so that means 3 of the numbers, 3 out of the 6, exactly half of them are a prime. So therefore, it's an even chance. Okay, well done. In your notes copy, I would like you to pause the video and to copy this scale. Remember that when we draw a line in mathematics, we use a pencil and a ruler and the words in pen. And although on my screen I have the word even chance written in red, we know that we try not to use a red pen so that we can keep red for corrections and marking. Once you have recorded this into your notes copy, then you continue to press play. Okay, so we've established that if we use a word to describe the chance of something happening, then that's called likelihood, and we can use a likelihood scale. But what if we want a numerical description? Well, that is what we call probability. So likelihood is answering in words, and probability is answering those same chances with numbers. And those numbers can be in 3 different formats. So here we have the probability scale. So just like the likelihood scale, it is a line, and down here represents absolutely no possibility at all. Okay, it's definitely not happening. And up here, absolutely it is. But instead of using those words that we discussed earlier, we've got 3 different formats to describe the chance of happening, and they're all using numbers. If you look at the blue, the first row, we can describe probability as a fraction. So starting from 0 or 0 as a numerator with any number as its denominator. And ranging all the way up then to a whole fraction, which means the whole thing, which we know if we were to split a chocolate bar into 4 parts, and if we wanted all 4, that would be the exact whole thing. So that would represent most definitely something happening. And if we had none of those chocolate bars, then it represents none of it happening. And then the even chance, remember that from likelihood? Well, as probability, that means it's just as likely to happen as not. So there's a half chance. A half chance that the coin might land on a head, or a half chance it might land on a tails. So the first row shows the use of fractions to describe probability. So we have everything between 0 and a half, smaller fractions, represent the unlikely section. And then every fraction from a half up to a full whole represents the likely section, for example, 3/4. Now the second row shows us that we can use decimal numbers to display probability. But what's really important, and what some students find quite difficult to learn, is that the numbers do not go from 0 to 100. They go from 0 to 1. So 0 represents absolute no chance, and 1 represents complete certainty. So in the middle, even chance, well, there's a half probability, and therefore we know that a half is 0.5 as a decimal. And then the last possible way of writing probability is using percentages. Now we know from the word percent that means out of 100. So the percentages go from 0 up to 100. So 0% absolutely can't happen. 100% it absolutely will. I'm 100% sure. In the middle then, it's 50% chance. And as we said before, in between 0 and 50 then, representing likelihood of unlikely, but would be any of the percentages like 1%, 2%, all the way up to 49.9%, in between 0 and 50. And then likewise, if you take 75%, for example, that's in between 50 and 100, so it represents somewhere in the likely zone. So let's revise some of the words and theory that we've learnt so far about probability. So we know that a trial is the act of doing an experiment. For example, flipping a coin, rolling a die. And then an outcome is one of the possible results from that trial. For example, there is a possibility of rolling a die and getting the number 4. Okay, so this leads us on to another keyword that we haven't talked about in great detail yet. Now, an event is the occurrence of one or more specific outcomes. So in other words, if we're interested in getting a particular outcome, then we're interested in what the event is. So getting a 1 or a 2 is an example of an event when rolling a die. So if I ask you, what is the chance of getting a 1 on a die, then I'm asking you about a specific outcome, an event. Now we know that the list of all possible outcomes in a trial is called the sample space, And in previous lessons, we've learned how to show the sample space with systematic listing, two-way tables, and tree diagrams. And our example of the sample space for rolling a six-sided die is the numbers 1, 2, 3, 4, 5, and 6, the set of those 6 numbers. Okay, so let's have a look at our probability scale. So as you can see, I have used decimals on this scale. And we know that decimal format ranges from 0 for definitely can't happen, 0.5, it's just as likely as it is unlikely, and 1 for it's definitely going to happen. The greater the likelihood is, the closer to the number 1. The less likely something is, the closer it is to 0. So let's have a look at some events and see where they would be lying on the probability scale, remembering that we would have to put an arrow then to show exactly where we think it would go. Well, getting ahead when you flip a fair coin is exactly halfway at 0.5. Christmas will be in December. Yeah, it's not something that happens in summertime. Well, not unless you're in Australia. So it's still going to be exactly definite, it's happening, so it's the probability of 1. What's the probability that it will rain somewhere in Ireland next week? Well, we get a lot of rain, and it has been raining a lot recently, which means it's pretty likely. I cannot say certain, because maybe it might not. It's not 50-50 either. I can't be certain. It's definitely either likely or unlikely. So it's somewhere in this scale here, and I'm going to put it slightly closer to certain than I am to even chance. So I'm putting my arrow here. That someone in your family will win the lottery, well, that's kind of unlikely. Not impossible though, so maybe here. That next year I will be a year younger. No, as time goes on, we get older. That's definitely not going to happen. So that goes here. Okay, I want you to imagine that this pole is a scale that we're going to use to represent likelihood, which we know is in words, and probability, which is in numbers, either as a fraction, a decimal, or a percentage. So let's go ahead and label our scale. So first of all, where would I put this? It's the likelihood of an even chance, the probability a half, 0.5, or 50%. Point to the screen. Where do you think it will go? So it should go exactly in the middle there. Okay, next. Impossible. That's the word, so that's the likelihood, and the probability is either 0 or 0%, 0.0 as a decimal. So where does that go? It goes right at the end. There's absolutely no chance of something happening if it's impossible. Okay, what about then something is certain? So the likelihood is certain, and the probability is the number 1, a whole, or 100%. So point to your screen. Yeah, it should be exactly at the very end. Okay, so we're nearly there. Next, we've got the word likely, so that's the likelihood description. And then we've got the measurement there for probability of the capital P is representing probability being between 0.5 and 1, where it's larger than 0.5 but smaller than the number 1. So where would that go? Well, it represents this entire section in between those two. So we're going to put it there. And then lastly then, unlikely, it's the likelihood, and the probability then is between 0 and 0.5. So that's going to go in this section here, everywhere from just a little bit bigger than impossible and all the way up to a little bit smaller than an even chance. So this entire section. So these two words and numerical representations are for quite large sections, whereas the even chance, or a half, 0.5, 50%, certain, or 1, or 100%, and impossible, or 0% are exactly in specific locations. Okay, so now we have labelled our scale, we are going to put some events onto our likelihood and probability scale. So first of all, where should I put Christmas Day will be on the 25th of December? So you'll notice that there is an arrow at the top of the page so I can be exact. Where am I going to put that? You can point to your screen. Well, Christmas Day never changes. It's always the 25th of December. So I'm going to put my arrow here pointing to my probability scale. The arrow is really important. If you didn't have the arrow and you just had it somewhere near there, well, the examiner isn't sure if you mean exactly here or here or here. So we have to have an arrow to be exact. Okay, next. What is the chance that tomorrow it will rain? Let's have a look outside. Well, it's not very nice now. It's quite possible it will rain. We can't say it's certain, and we can't say it's impossible. It's also not 50-50, because there are a lot more than one or two types of weather. It could be windy, it could be snowing, it could be a gale. So all I can say is that it's probably quite likely. Where would you like me to put the arrow? I'm thinking it's probably around here. So a little bit greater than halfway between even chance and certain, but anywhere in this region in between those two would be correct. My probability then would be either a fraction, a number from 0 to 1, so a decimal, or a percentage between 50 and 100. Maybe about 80%, 0.8. Okay, next. What is the probability that you will win the lottery? Probability I asked for. Well, that means I can't give a word answer. It has to be a number, either a decimal from 0 to 1. It's definitely not 0, because it's not impossible, so long as I buy my tickets. And it's not 1 certain. It's not an even chance either. It's highly, well, in likelihood terms, it's unlikely. So that means as probability, it's somewhere above 0, but not as far as 0.5. But I'd say it's pretty close to it. Maybe around here, 0.1, maybe 10%. That's probably being a little bit optimistic. Okay, lastly then, what is the chance, there's 2 apologies, that you will roll an 8 on a standard die? Well, that's impossible. There's definitely not a number 8 on a die, so we're going to put that right here. Impossible for likelihood and 0 for probability. We'll just move our lottery chance. My luck has obviously gone up, so I'm increasing my likelihood. And then last, a newborn baby will be a girl. Well, it's either a boy or a girl, so we can say that's definitely going in there at a probability of 50% or 0.5 or a half, with the likelihood even chance. I would like you to record this probability scale into your notes copy underneath where you had just put your likelihood scale. Please remember the use of pencil and pen when appropriate. And again, using different colours can help to distinguish between fractions, decimals and percentages, but let's try not to use the red. Once you finish recording it into your notes copy as neat as possible, then you can continue to press play. So the last word before we end this lesson is to just remind you one of the main important things when answering a question in an exam is to check what wording the question has given to you. Have they asked you for likelihood, so your answer needs to be a word, or have they asked you for the probability? If they've asked you for the probability, then you must represent your chance using one of the three methods. If they ask you for a particular method, for example, give your answer as a fraction, then you must use that correct method. If they do not tell you which method that you must answer in, then it is up to you which you choose. However, you do not need to write all three. Your homework today is from page 127. It's exercise 8.3, and I'd like you to do question 2, which is about likelihood. Using a likelihood scale, you are to decide where some events would go. Number 4, which is probability scale, and again, you are to decide whereabouts on the probability scale some events will go. And then over the page, question 8. I hope you have a lovely weekend, and I will see you next week.